Hi, this is the first video for Year 2, Chapter 2, which is functions. So this chapter is all about different types of graphs, some of which can be classed as functions, and there are lots of properties to do with functions that you need to learn. Some graphs, though, can't be classed as functions. So the first video we're going to look at what makes a graph a function and what makes it not a function. Because there's going to be lots and lots of graphs that need to be sketched, it's probably a good idea to just review different types of graphs. So what I want you to do is pause the video and just see if you can remember how to sketch those 8 graphs. Okay, so remember you're going to mark on where it crosses the axes. If possible, you're going to mark on the equations of any asymptotes, if possible. Okay, so see what you can remember. Right, so if we just go through each type, I'll show you what they look like in a second. But this one, this is a quartic. Quartics are either that shape or that shape, usually. This one, you've got a positive x to the power 4. X times x times x times x is x to the power 4, which you end up with this W sort of shape. Okay, so you're going to end up with a W sort of shape. There is a repeated factor at 1 where x equals 1, so it's going to sit on the x-axis there. This one is a reciprocal, but it's an x 1 over x squared. So that means that it's going to look like that sort of shape. This one is an exponential, so it's just that's been transformed. So that exponential is that sort of shape. This one, this is a cubic. Cubics generally either do that or they do that. In this case, you've got a negative cube term, so it's going to look like that. This one is a reciprocal. Reciprocals look like that or like that. In this case, it's a negative reciprocal, so it's going to look that sort of shape. This is a log graph. So you sketched some log graphs in the previous chapter. Natural log looks like that sort of shape. Cos looks like that. And this, you should recognise, is a circle. So the actual graphs are that. So there's the quartic. So it's got x-intercepts at -2 and 3, and it's got a repeat at 1. So that's where it turns on 1. 1 over x squared minus 2 looks like that. That's your exponential. That's your negative cubic. That's the reciprocal. That's the log. That's 2 cos x. And there's the circle. Okay. If any of those were particularly rusty, it might be worth just going back and having a look at, to remind yourself how to sketch some of those. It is crucial for upper 6 maths that you recognise and can efficiently sketch lots and lots of different types of graphs. Okay, so let's get on to functions. These are going to be the main objectives throughout these next set of videos. So first of all, we're going to look at types of mappings, what makes a function, and introduce the domain and range. Then there are different things that we can do with functions. We can do something called composite functions. We can work out the inverse of a function. We can work out a modulus of a function. we can transform different types of functions. Okay, so this first video is about what makes a graph a function and what makes it not a function. And it's to do with a mapping. Okay, so there's loads and loads and loads of different types of graphs, and a graph is just a relationship between the x-coordinate and the y-coordinate. And that's all a graph is, and it depends on the relationship. Depending on the relationship will give you then the shape of that particular graph. Okay, we call that relationship a mapping. So a mapping is a rule that transforms one set of coordinates into another set of coordinates. Okay, so let's say we've got 1, 2, 3, 4. Those would be our inputs. So you'll have been doing function machines since you were probably in year 7. This would be the input, and then through some rule we might end up with an output. So like that. Okay, so 1, 2, 3, 4 is the input. The output is 5, 9, 13, 17. So 1 has been mapped to 5, 2 has been mapped to 9, and so on. Hopefully you can see that the rule to get from here to here is going to be, if I call that x and I call that y, the output is 4 lots of the input plus 1. So this is a linear mapping that maps those x-coordinates to those y-coordinates. A function maps a set of x-coordinates to a set of y-coordinates. But there are some mappings that cannot be classed as a function. So what I'm going to look at now is there's 4 different types of mappings. Some of those mappings are functions and some of them aren't. Okay, so relationships between x and y that are or are not functions. So you can see here, I've split my page into 4, and there are 4 different types of mappings. And I've just chosen these equations just to illustrate the type of mapping. So 1-to-1 mapping. This is y equals 2x plus 1. So if I draw some little mapping ovals, here's my x, here's my y. So 1 would map to 3, 2 would map to 5, and 3 would map to 7. And as you know then, that creates that line, 2x plus 1, that looks like that. Okay, there is one x-coordinate. Each one x-coordinate maps to one y-coordinate. So that is 1 to 1. For every one x-coordinate, there is one y-coordinate. And lots of graphs are 1-to-1. See if you can think of other types of graphs that you know that are 1-to-1. Y equals x squared minus 3. Well, again, if I draw my little ovals, here's x, here's y. So if I choose x equals 1, well, x equals 1, 1 squared minus 3 is minus 2. So 1 maps to minus 2. If I choose -1, -1 squared minus 3 is -2. If I choose x is 2, 2 squared minus 3 is 1. If I choose x is -2, -2 squared is 4, minus 3 is 1. So here there are many x coordinates that map to one y coordinate. So that is a many to one. That looks like that-ish. So many x coordinates map to one y coordinate. So that is a many to one relationship. One to many, hopefully you're sort of seeing the idea now. There's x and y. So y squared equals x, that's an example of a one to many relationship or equation. If I say x equals 1, well, y squared will equal 1, so y will be +1 or -1. If x equals 4, then y squared will equal 4, so y will equal 2 or -2. So here there is one x coordinate that maps to many y coordinates. That looks like that. If I was to plot it. And then this one, hopefully you'll notice that it is a circle. So let's say x equals 1. If x equals 1, 1 plus y squared equals 4, so y squared will equal 3, so y will equal √3 or -√3. If x equals -1, -1 squared is 1, so 1 plus y squared equals 4, y squared equals 3, so y will equal √3 or -√3. So when x equals -1, y will equal -√3. So here there are many x values that map to many y values. And as you know, that is a circle, centre of the origin, radius 2. So we've got 1 to 1, many to 1, 1 to many, and many to many. Those are the different types of mappings. Those are the different types of relationships between x coordinates and y coordinates. And as you can see, they produce different types of graphs. Okay. Now there are only 2 of those that can be classed as functions, and we can use function notation for them. And the ones that are functions is this one here and this one here. So basically the ones where it finishes with a 1. So 1 to 1, many to 1, they are classed as functions, and we can use function notation to replace the y. We could use function notation to replace the y there. Okay, they are classed as functions. Something to many, they are not functions. And you, if you think back, when have you ever seen function notation on circle questions? Well, you haven't, because they're not functions. Okay, so something to 1. That's because, here's a definition, a function maps a set of x coordinates, which we call the domain. So here's our x coordinate, to a set of y coordinates, which we call the range, where every member of the range, so this one here, is uniquely defined for values in the domain. So these have to be unique. There can only be one of each y coordinate. Okay, so if we have this mapping here, like we saw in the previous slide, then we could say, so this is our domain, which are the x coordinates. They map uniquely to the y coordinates. There is only one y coordinate. Okay, so this has got to be 1, and these values we would call the range. So we could write that using function notation. In this case, it would be 4x plus 1, as I've already said. Okay, so here's just a little question for you. Types of things you might have to use. Given that f of x equals 4x squared minus 3, find the values of a such that f of a equals 45. So think about your previous knowledge of functions, function notation, which we've done before. Okay, this thing here, whatever is in here, is representing the input. And then this whole thing here, well, that's a bit like writing y, isn't it? So this is saying that when x equals a, y equals 45. So if we substitute that in, 4a squared minus 3 equals y, which is f of x, 45. And then we just can solve that. Add the 3, divide by the 4, and then square root to get to plus or minus root 12, which is plus or minus 2 root 3. Okay, so you'll see function notation where you might have to work something out. Okay, but that is what a function is. So if the x coordinates map to one y coordinate, so if it's 1 to 1 or a many to one mapping, then that can be classed as a function. And you need to be able to spot from the graph what sort of mapping it is and whether it's a function or not. Now, one way of little cheat to spot if it's a function or not, it won't tell you necessarily what type of mapping it is, but it will tell you if it's a function or not. If you just imagine drawing a vertical line through any point on the graph, if your vertical line crosses the graph once, then you know you've got a function. If your vertical line crosses the graph twice, then you know you don't have a function. So that's an indicator of whether it's a function or not. Then you just need to decide what sort of mapping it is. Okay, so think of y equals sine x. First of all, think, is this a function? And then once you've established that, decide what sort of mapping it is. Well, first of all, you could draw a vertical line anywhere through y equals sine x, which means it's a function. So yes, it's a function. So is it a one-to-one function or is it a many-to-one function? Well, for this, you just need to think, are there more than one x value that maps to a one y value? And the answer is yes. So for example, here, if I go up to here and then across to here, this x value and this x value map to the same y value. So there are more than one x value which maps to the same y value. So this is many to one. So it's a many to one function. Y squared equals x cubed. Well, vertical line through it. It's not a function. What sort of mapping is it? Well, that one x value maps to that y value, and that one x value maps to that y value. So there is one to many. So that is a one to many mapping. Here's an ellipse. Okay, so again, vertical line. It is not a function, and in this case it's going to be similar to the circle. There is many x values that map to many y values. So that x value maps to the two y values, that x value maps to the same two y values. So there are two x values that map to the same two y values. So that is many to many. And then this is an exponential graph. Okay, vertical line, it is a function. Is it one to one or is it many to one? Well, that one x value there maps to that one y value there. So that is a one-to-one function. Okay, so hopefully you've got a bit more understanding about what makes a function and different types of mapping. I also mentioned the domain and the range. So the domain, this is the possible set of x values. That's what the domain is. And the range is the possible set of y values. Now, depending on the graph will depend on what the possible set of x and y values are. Sometimes you might restrict the graph, so you only actually want a particular part of that graph, in which case you might restrict the domain, in which case the range would then be restricted. A graph might naturally have its own restriction based on what type of graph it is. We're going to look in the next video about what domains and ranges are and how to graph them and types of graphs and what their domains and ranges are. You just need to know the notation, and you'll have seen these throughout year one on different questions, but without really paying much attention to them. So you might have, for example, you might see a function written like that, and then it might have a comma, and it might look like that. This would be the definition of the function. This means that x belongs to the set of reals. So that funny E means belongs to, and that funny R means the set of reals, which basically means any number. So x, so that is saying that x can be anything. So this is notation for the domain. You might see something like that, and it might say that, but it might also then say that. So this is a reciprocal graph where it's saying x can be anything, but it can't be 0. And in this case, it can't be 0 because that would be undefined. Okay, so you'll see this and this. It might, that particular question, it may just say that. Okay, it doesn't have to say the other bit. So you'll see that sort of thing. You might have that, and then they might decide that they only are interested in positive values of x, so it might be restricted. But all of this is notation to tell you what the set of x values can be for that particular graph. All right, and a function really cannot be written in a question unless you have got a domain attached to it, because you've got to know what part of the graph that they want. Are they allowing you to consider every graph, every point, or are you only interested in a bit of a graph? Okay, the range follows. So once you've got your function and your domain, then the range, the notation for the range is the same essentially, apart from instead of x, you would use f of x. So, or, I suppose, you would use that. But that is preferable, as you'll see later on. Okay, what you mustn't do is forget the f if you're talking about a range, because if you've got, even if you've got the numbers right, they won't give it you. Okay, or it might be, you might, for example, have a range where it's like that. Okay, or if you might be told that you've got a graph and you're only interested in a particular set of values, then the range you would give in the same sort of style. Okay, so the domain, the domain is the set of x values. Sometimes you'll be allowed every point, sometimes they might restrict it. The notation for the range, you just use f of x, and that's representing the set of possible y values. Okay, so that's going to be the end of this first video. In the next video, we will be sketching lots of graphs and talking about what the domain and range are for each graph.